And the answer to that is no. Not even in the mystical world of special relativity can you see the effect before you see the cause. And the reason here is that if an event on A causes an event on B, then the light from A will come direct to us at point O, but the light from B cannot start to come to us until the information that is going to cause it has arrived from A. And there is no way that light can travel from A to B to O faster than it can travel from A to O. So you always see the cause before you see the effect. What about simultaneity? We are suggesting that the time measured by one person is not necessarily the time measured by another person. But what happens if we're thinking about clapping your hands together? Or maybe two cars hitting one another in the road? Is it possible that some other observer in the universe will see your two hands missing one another, or the two cars missing one another? In other words, is that kind of simultaneous event observed by somebody else as non-simultaneous? And the answer is no. And the reason is that when you have a simultaneous event happening at the same place and at the same time, then as far as our equations are concerned, the difference in t time is 0 and the difference in x is 0. And so if you have the formula t prime equals t minus u over c squared x all times gamma, if t is 0 because the two events happen at the same time, and x is 0 because the two events happen at the same place, then t prime is also going to be 0, and consequently everyone in the universe will see your two hands clapping, and everyone will see the two cars hitting one another. We're now going to move on to a concept called a 4 vector. This is necessary in relativity because we have to introduce the concept of space-time. Space-time is simply the normal 3 dimensions of space, up and down, side to side, back and forth, which we typically label x, y, and z, with a 4th dimension, which is time. And so we create a 4 vector, which I'm going to call capital X, and the 4 components of that vector are t for time, x, y, and z representing the 3 spatial dimensions. In fact, we relabel that as capital X equals x0, x1, x2, x3. And the reason we do that is because sometimes physicists like to work in more than 4 dimensions, and that way they can have as many numbers as they like, whereas if we stuck with letters we might run out. But x0 is in the wrong dimensions. x0 is a measure of time, whereas all the other measures are of distance, and it's not good practice to have 2 different dimensions in a single vector. So in order to make x0 the same units as the other components, we are going to say x0 equals time times c. C is a constant, universal, everyone measures it the same. And if we say that x0 equals ct, then all of those 4 components of the x vector are all measures of distance. We're now going to set u over c to be beta. x1 prime equals x1 minus beta x0 divided by the square root of 1 minus beta squared. Because beta, as I've said, is u over c, and x0 equals ct. Similarly, x0 prime equals x0 minus beta x1 divided by the square root of 1 minus beta squared. For ease of calculation, I'm going to ignore x2 and x3, and we're simply going to work in 1 dimension of space, and one dimension of time. I am going to create a term called s squared, and I'm going to define that as x0 squared minus x1 squared. x0 squared, remember, is essentially time squared, but multiplied by c squared, minus x1 squared, which is a spatial coordinate squared. Now, let's look and see what happens to the term x0 prime squared minus x1 prime squared. Well, that equals x0 minus beta x1 all squared times gamma minus x1 minus beta x0 squared times gamma. And that, if you multiply it all out, comes to the following: x0 squared minus 2 beta x1 x0 plus beta squared x1 squared minus bracket x1 squared minus 2 beta x1 x0 plus beta squared x0 squared all over 1 minus beta squared. You will see that the 2 beta x1 x0 terms cancel, and that leaves us with x0 squared plus beta squared x1 squared minus x1 squared minus beta squared x0 squared, all divided by 1 minus beta squared. And that is x0 squared into 1 minus beta squared minus x1 squared into 1 minus beta squared, all over 1 minus beta squared. And that equals x0 squared minus x1 squared. What have we shown? We have shown that x0 prime squared minus x1 prime squared equals x0 squared minus x1 squared. We have found a term which is invariant no matter which frame of reference we are in. S squared is common and measured by everybody.